with most CAD packages, I mean, you're working in a 3D environment, but on a two-dimensional computer. So we need to visualize this three-dimensional object on our two-dimensional computer screen. So we'll need to be able to spin the model around, use cutting planes to view the interior of the model, or possibly turn off portions of it. But we'll need to be able to manipulate this 3D geometry so we can see all aspects of it. It says, in addition to viewing the model's geometry, we will also like to be able to view the attributes of the model, things like scantlings, loads, and some of these we viewed yesterday, where you could view things like the plate thickness, the amount of corrosion applied throughout, the stress contours from the result, and so forth, along with some of the hull loading parameters that we also looked at a little bit yesterday, for like the load distribution along the length of the hull, or say the buoyancy distribution. When we look at Maestro, the screen is broken up into different regions, and we have the main modeling space in the bulk of the screen here. And you'll see the planes defining the X, Y, and Z axes that we're working in. You'll see on this one, it has a black background, and on the instance that I just brought up, you see the white background, which is the default, but that's one of the things that we can easily change. To the left of the screen, you'll see a number of icons, and this represents the pre-processing toolbar. And you'll use this quite a bit for building the model. Across the top, you'll see some of the standard toolbars, the standard Windows toolbar for opening and saving files, creating a new model, as well as the help dialog. There's the actual menus up above, and then there's the viewing toolbar. Now, this toolbar, there's actually a few more icons. There's a sort of continuous improvement in Maestro, where based on user feedback or just our own procedures, if we find something seems to be taking too long or takes too many mouse clicks to get the operation done, and you spend a lot of time doing that, those are the things that tend to get a high priority for getting either a new function installed or something to help streamline the either model building process or the process of just interacting with Maestro. So you will see a few additional icons on the live installation of Maestro on your computer that you don't see on this one. So the viewing toolbar has a number of icons in here for working with the model and the display of the model. The post-processing toolbar here is for this drop-down list is for your loading conditions. So you can select, you can have any number of loading conditions defined, and this allows you to quickly switch between them. And then there's a button for hydrostatic balance, showing the contours on the hull of your results plots, and animation, and a couple other post-processing tools. The parts and groups tree is this dockable window on the right, and you'll see two tabs at the bottom, the parts tree and the groups tree. By default, starts with this layer top, and this is the hierarchical view of your Maestro model. To the right of it, you'll see a refinement element toolbar, and this is for when you're working with the model, being able to refine various pieces of the model, such as subdividing existing quads, splitting a quad into a quad and a tri, splitting a quad into two tris, and so forth, splitting a beam, merging them back together, things like that. And we'll get into that a little later. At the bottom of the screen, there's another dockable window down here, and these windows can be resized as well as detached and moved around the screen. But at the bottom, it currently is labeled output, but you can see there are three tabs at the bottom for this results window. And you can have it display the current command, a text box for output, or a grid view for, say, listing all of the elements that are currently being displayed, or perhaps all the nodes that are currently displayed. With the command line, you can type in various commands, although typically you'll be interacting with the model primarily through the mouse, but you are able to type in commands manually on this line. And whenever you type in a command and hit enter, the final version of the command is echoed to the right. And this is a non-editable box, but you can copy the data out of it and store it in a text file elsewhere if you want to go back to it later. Things like the view setting, as we rotate the model around, it's setting a heel, pitch, and yaw angle to define the angle that you're viewing or the point of view that you're viewing the model from. And once you interactively spin the model around and find just the right view, you can simply copy that command and then later paste it back into the command line here and recover that exact angle. And in the lower right, you'll see a status bar, and this shows the current heel, pitch, and yaw of the model. Also the units that you're currently working in, plus and minus, which just indicates the status of this button here, which relates to these spin buttons. You can incrementally roll the model over, you can pitch the model, and you can yaw the model in 15-degree increments, and you just toggle between plus and minus if you want to rotate in the positive direction or negative direction. This just tells you which way it's currently set. The top that you see displayed here is the current part in the parts tree, and then you also have the status of the caps lock, number lock, and scroll lock buttons.